name's Greg Meyer with Mackay Manufacturing. This is a Willemin 7-axis milling machine. It's a Swiss-made machine. Takes a fairly small footprint of a 6-foot bar feeder. This is what goes into the bar feeder. So you've got a 6-foot bar loaded into the bar feeder, and then it pushes forwards into the machine. So it's actually, this is the only bar-fed mill that I know of. Basically, you take a piece of bar stock, put it in the backside of it, feed it in, and it'll take bar stock and turn bar stock into finished parts with pretty much no human intervention between the bar stock and the finished parts, other than setup. It's got a 24 tool magazine, and it'll do turn work, mill work, lathe work. We're going to go ahead, we're actually making this part right here. That part right there has got both mill work and turn work on it. So we start out by turning the part, and then we're going to do some mill work on it. There's some ramps on the inside of it, so we do some contouring, some full 4th axis contouring inside. What we're going to do is we're going to come in, set the head down beside the machine, and we're going to draw the bar out, clamp the bar, and then it has a check to make sure that the bar pulled out. If the bar didn't pull out, the machine will stop on its own. So we're going to face turn and then turn the diameter on the part itself. We're running oil in this machine. Oil gives us a lot better surface finishes, a lot longer tool life. Along with that, we run stainless steel, aluminum, titanium in this machine. It's got a fire tracer or fire protection system in it, so if we're running titanium or some kind of flammable, semi-flammable material, if we do get a fire or a flash fire in the machine, it'll automatically put the fire out. So right now we're rough boring the center of the part out to generate a hole so we can go back in and do some mill work in a little bit. It's got a laser tool checker on it. Right now we're checking to make sure that the tool's still there. And that is to prevent further catastrophic injury to either the part or the machine. If you have a tool that's broken or dull, the machine's going to stop and tell you that it's broken, so you don't stack up broken tools in behind it. So right there we cut a groove in the back of the part, so that's basically the thickness of the part right now. Then we're going to go in, we're milling inside the pocket, rough milling the pocket on the inside. It's about a 20-minute cycle to go through this. Right now, the advantage of using this machine is because it's a bar-fed mill, so we can start out with this material is A2 tool steel. So we can start out with a piece of A2 tool steel bar stock, and it feeds into the machine. And with the full 5-axis milling that we're doing here, we can take that piece of bar stock and turn it into a complete finished part without anybody having to touch it. Less human interaction between 2 different operations. It runs a little bit faster here. We have 30,000 RPM spindle here for doing our mill work, where we used to do it in our vertical mills or our horizontal mills, which have somewhere between 12 and 20,000 RPMs depending on what machine it's in. So the mill work we're able to do at 30,000 RPMs, and the lathe spindle has the same spindle RPM as what the lathe department has, so we don't have to batch and queue parts in between operations. Setup on this is about a 2-hour setup, where in the past, if it was running through the lathe, you'd probably have an hour to 2 hours of setup in the lathe, and then when you go to the mill department, you'd have 3 to 4 hour setup. So you're going to cut your setup at least in half, put the tools in, bolt the jaws in, put the program in, so you're down to about a 2-hour setup. You got a chiller that chills this one is the electrical cabinet. This one's a mechanical cabinet. So we're keeping all of the ways, the ball screws, all of the electronics, because all of your electronics are generating a lot of heat. So we want to keep the inside of the machine at 70 degrees. So both that chiller and that chiller are designed to keep the inside of the machine at 70 degrees, as well as chilling the coolant or the oil to 70 degrees. So you take a part that is room temperature. That bar stock right now is 70 degrees. You load it in the bar feeder. When it goes through the process, the entire process keeps it at 70 degrees, so you don't get the thermal expansion either. So right there, it came over, it's blowing off. It's blowing off the part and blowing off the vise. Now the vise is going to come up and grab that part. Okay. So now the vise comes closed on the part. We're going to come over and check our tool. Then we're going to grab a saw and we're going to saw the back of that part off. Okay. So we're going to flip down. We're going to saw the part off, and then after it saws it off, that vise will then flip down, and then we'll do a little bit more mill work, and then we'll be done. Okay. So now we've got the part sitting there. I'm going to change tools. We're going to come down and mill. So now we're cutting the ramp, and we're going to use our 3-axis milling and come in and stitch that ramp inside. When we quote jobs, they send us a 2D drawing, and then we'll take the customer's solid as well. Come up with a quote on what we're going to charge them to make the part, and while we're doing that, we kind of devise a rough draft plan in our head as to how we can hang on to it and how we can actually manufacture the part. There's times where we'll go back and talk to the engineers and say, hey, we really need a fillet radius in here or radius in here in order to make this thing manufacturable. Then when we get the job, that solid file then goes to our programmers who design the tooling, how we're going to hang on to it, and write the programs to manufacture the part. We've got some really good guys working in programming. So they, as a group, they'll come up with, this is what we want to do for tooling to hang on to the parts. We model the tooling in SolidWorks and we give it our tooling department, who then takes the solids that we make and build the tooling to hang on to the part. Okay, so now this is going to come down. That right there is a complete cycle.